Hello, welcome to this session. In the previous session, I talked about socket programming. Now, the socket programming is based on TCP mode of communication. What is the important point about TCP mode of communication? There are two important points. One, the client and the server actually have the physical connection with each other. That means they exchange the socket so that the client come to know which one is the server and server come to know which one is the client. That is one point. The second point is TCP mode of communication actually based on handshaking protocol. So what is handshaking protocol? Whenever the client or server any sends a packet to another fellow, then that fellow need to send an acknowledgement for that particular packet. Now what happens for that acknowledgement? Whenever let's suppose the server is sending a packet to the client, so the client need to send an acknowledgement. Now when that acknowledgement is received by the server come to know that the packet is delivered successfully. Now there may be two cases arise. One, that the packet itself get lost. In that case, the client is not sending any acknowledgement for a certain wait period time. Then the server understand that the packet is lost. Now there is maybe another scenario where the packet is delivered successfully and client has sent the acknowledgement, but the acknowledgement get lost. In this case also, the server understand that the packet is lost and it resend the packet. Now there may be some duplicate packet problems, but that problems can be solved with some sophisticated algorithms. So my area is not on networking, so I am not talking about that. So somehow at the end of the communication, server is giving guarantee that all the packet is delivered to the client successfully. Now this means the protocol is very reliable. That is why the TCP is reliable. TCP is reliable because of the handshaking protocol. So these are the two very important points about the TCP protocol, and that's why the socket programming which I discussed earlier is also reliable. But that reliability comes with the cost of a delay. What is that delay? Whenever there is a packet sent by the server, the client need to send the acknowledgement. So if server is taking say 5-minute time to deliver the packet, then the next packet will be delivered after 5 minutes more, that means after 10 minutes. So there is a cost for processing the acknowledgement. That cost is for the processing the acknowledgement. So sometimes reliability is an important aspect, sometimes it not. Sometimes the delay cannot be tolerated. I give you a practical example where the delay should not be tolerated. That example is live streaming. Suppose there is a match playing on some ground, and that match should be broadcasted. So if there is a delay, then if there is a delay, then it might possible that the bowler throw the ball at time say 10 a.m. and then the batsman hit the ball at say 10 a.m. So there is a 10-minute gap possibly between the ball throw and batsman hit the ball. So that kind of problem will arise if we are actually taking that delay into the consideration. So that should not be done in case of live streaming. So this is a practical example where the TCP protocol is not suitable. So what is the suitable protocol here? The suitable protocol here is obviously the UDP. Now what happens in the UDP? UDP stands for, first of all, UDP stands for user datagram protocol. So what is the, how that UDP works? Here the server sends the packet without expecting the acknowledgement from the client side. Now the server is not expecting the acknowledgement, and that is why the client is also not sending the acknowledgement. So there is no delay occurs in the acknowledgement processing. But yes, that due to the lack of the acknowledgement, this kind of protocol is not reliable. So there is a reliability issue if we take care of the acknowledgement. But if we are not taking care of the acknowledgement, then there is no reliability issue. But yes, at that time the processing will be a little faster. So if we require the fast processing, we go for the UDP. If we will require reliability, we go for the TCP mode of communication. So each mode has its own importance. We have already seen the TCP mode of communication by with the example of socket. Here we will see, in this session we will see the example of UDP mode of communication. So whenever we are working on UDP mode of communication, then the socket will not come, but still we require a socket, but that is not the handshaking socket. So we require datagram socket. This socket, this class is available in java.net package. Now this class has three important constructors. One is public data this is a default constructor, and what this constructor actually does, it basically binds with a port, it binds with a port, it actually binds with a port which is chosen at runtime and which is also unused. So what it actually does, it scans the whole system and finds out the unused port and bind the program with that particular port. Now it actually uses local host. It actually uses the local host machine. There is another constructor called public datagram socket, and then it is a port number. Now it actually binds with the specified port. So whatever port we specify here, it will try to bind the program with that particular port, if that port is free. If that port is not free, then it will throw the exception. So this is the second constructor. Obviously it is uses the local host. The third constructor available is public datagram socket, and it actually requires two things: inet address and int port. Now what this constructor does, it actually binds the program, binds with a specified port on a specified address. So whatever address I specify here, the datagram socket will be bind on that port and that address. Now there is one important conception. What is this inet address? This inet address is a class available in java.net package, and it actually represents IP address in the byte form. So inet address basically represents the IP address in the byte form. Let's take an example. Let us suppose the IP address is 1.1.1.1. Now this 1.1.1.1 is obviously understandable by a human being. It is not understandable by the machine. Machine only understands bytes. So what is the byte representation of this IP? 1 2 3 4 5 6 7 1 1 2 3 4 5 6 7 1 1 2 3 4 6 7 1 1 2 3 4 5 6 7 1. So this is basically the binary representation of this address, and inet address is basically representing this one. So if we supply this IP address, the inet address actually converts it into this particular form so that it will be understandable by the machine. So now this constructor is used at server site. Now in case of datagram, if we are talking about the datagram or the UDP protocol, the server is not the right word. The word should be used here is the sender. So this particular socket, this particular constructor should be used at the sender site, and this particular constructor should be used at receiver site. Okay, so let's use this conception and let's work on the coding. So for the coding, I will create two projects. One is UDP sender, and another project I want to create is UDP receiver. Now let's first work on the sender part. So we are creating a package here, org.leaves.sender, and then inside this package I am going to create a class called main or sender main, and that sender main should require a main method. So I am clicking on this. Okay, so this is the main method. Let's have the try catch block. And we should handle the exceptions. So I'm going to handle it like this. Okay. Now, since this is a sender, I need to use datagram socket equal to new datagram socket. Now, as I told you, when this constructor is used, then the server or the sender actually scans the computer and then figure out which particular port is not used, and this is that particular port is reserved for the communication. So let's see what the port is actually reserved by this socket or by this constructor. System port reserved, and that is socket dot get local port. And again I told you that whenever I am using this or whenever this constructor is used, the system or the host is the local host only. So if we try to print the IP address of the local host, it will print 0.0.0.0. So let's see whether that output we are getting or not. System.out.println host. So what is the host? Socket dot get local address dot get host by name. So I am just printing the host name. Which one is the host name? So let's run this application first. And here the port reserved is 54587 and the host is 0.0.0.0. So basically it is using the local host and it is using this particular port number. Now let's send a message to the client. So here is the message which I want to send the client. Is equal to hello client. That's what I want to send to the client. Now if you want to send something to the client, then you need to use datagram packet. Now this is also a class in java.net package. Now what is this datagram packet? It actually represents the message which the sender want to send to the receiver. So this datagram packet actually represents a message. Now there are two constructors available in this class. One is public datagram packet, and then we need to specify two things here: byte array message, and then second we need to specify length. Now this particular constructor is used to prepare a packet. Used to create a packet. Basically it is used to create a packet for incoming message. So what is the meaning of incoming message? So what is the meaning of this statement? Suppose the server is sending some packet to the client. Now client need to receive that packet. So if we look at the packet, that packet actually contain the payload. Payload means the message available in the packet. So where that particular payload will be unloaded, so that area I am specifying by this message. So this message here actually represents area where the payload will be unloaded. Okay, and the second parameter is what? It is the length of the message, maximum length of the message. Basically I can say max length of the message which receiver can accept. Okay, so that is what the meaning of this constructor. So basically this constructor should be used at receiver side. Now there is another constructor available that is called public datagram packet. It is accepting these two parameters. Along with that, the third parameter required here is inet address and int port. So let's discuss about the parameter. The message parameter here doesn't represent the area where the payload will be unloaded. In this case, the message specifies the area where payload is kept. So if there is a payload, then where is the payload that is specified by this message? Then int the length part actually represents the length of the payload. The address basically specifies the client or the receiver address So which one is the receiver? Who will receive the message? Who will receive the packet? That is specified here. Now the last parameter is the port, is actually the receiver port. Through that port only the receiver will accept the message or the packet. So let's work on this. So this is the message which a sender wants to send to the client, but this message cannot be sent directly because the datagram packet will not accept high level data type like string. The data type or thing which is accepted by the datagram packet is the byte only. So we have the byte array, that is byte message is equal to message dot get bytes. So we got the byte, we get the byte representation of this message. Now then we also require the int length, that is equal to byte message dot length. So this length actually represents the length of the message which a sender wants to send to the receiver. Now we need to send the message, we need to prepare the packet. So here is the datagram packet equal to new datagram packet, and we are specifying byte message. Now as I told you, what this constructor does, it actually prepares a packet which is having this payload and this much length. So this byte message is actually the area where the payload is kept, and this is the length of the message or length of the payload. Now once the packet is ready, then we are going to send it, or the server is going to send it. So how to send? Socket dot send and then say packet. So this packet is sent to the client. Now let's have this system message sent. Now after the message sent, I can close the connection, I can close the socket dot close. Why? Because the UDP protocol is not working as an or not based on the physical connection. So when the server or the sender put the packet into the channel, after that the responsibility of the server is already over. So now it is the responsibility of the channel to deliver the packet to the client. Yes, I already mentioned that the packet may get lost, but in that case the server is not bothering about that. So the packet is sent here. Now let's work on the receiver side to receive that packet. So let's create the package again, com dot receiver, and in this package I require a class receiver main, and I also require the main method. Okay. So this is what the main method of the receiver. Try catch. Okay. Now, how the receiver will receive the packet? First of all, it need to reserve a well-known port. That port should be again I am making a mistake here in the sender side. The sender side will not use this constructor to prepare the packet. Yes, it required this thing, and then also it requires two more parameter. So what is two more parameter? First of all, it requires inet address, client address, or why not client, receiver address is equal to inet address by get by name, and then I am specifying the host, but here the client and server, or the receiver and the sender, is running on the same port. I need to specify local host. So this is the one part. The second thing we require is the port number of the receiver. That port number should be known to the sender in well before. So here int receiver port is equal to 8856. Let's say the receiver is receiving the packet through this port. So that two things we need to specify here. One is the receiver address, and the second is the receiver port. So that four thing is required when we are talking about the sender. Now we can move to the receiver. So how the receiver will receive the packet? The receiver must allocate the well-known port. So here the port is reserved by this datagram socket equal to new datagram socket, and then port, here the port I am using is 8856, and that is also known to the sender. So let's send it. Let's reserve that particular port for communication. Now through this particular port only the receiver will receive the packet. Now when the packet comes or arrives at the receiver end, then the receiver need to have an area where the payload will be unloaded. So here the payload will be unloaded, that is here the buffer is equal to new byte array. Now what is this 1024? It is the maximum length of message that a receiver can accept. Now fine, so we require a packet here, the datagram packet equal to new datagram packet, and we can specify the buffer and the length. Now what is the length? Length will be this buffer dot length. So the packet here is ready, and it is actually specifying where the payload will be unloaded and how much payload can be unloaded. Next by using this socket dot receive packet. Now, what is the meaning of this statement? The meaning of this statement doesn't mean that we are accepting this packet. The meaning is that whenever the packet arrives at the receiver side, then that packet will be accepted, and then a new packet will be created on behalf of that accepted packet. In other word, what I can say, the packet is just an what you can say, the packet is just the keyword for something. It is not the actual entity. Now, what is the meaning of packet? Actually, what happens whenever the server is sending or the sender is sending something, it is always sent in form of bytes. Bytes means a kind of electrical signal. When that bytes arrives at the receiver end, then receiver receives that byte and convert it to the packet. So that is what this packet is. This packet is not the packet sent by the server. Yes, it is containing everything about that one, but it is prepared on client side or the receiver side. Now the socket is receiving the packet, then what and all the payload will be unloaded here. Unloaded here, that area we have specified, it is still not unloading. So let's unload the payload. Packet dot get data. So when the packet receives that packet, the payload is stored here, and then we use the packet dot get data, then we are getting that much that particular message in the byte form. Now what happens at this time, we are specifying the area where the payload will be unloaded. When we say get data, the load will be unloaded in this particular buffer, and then it will return that same buffer again. So we can say buffer equal to this one. Now this particular buffer, this particular area contains the payload that should be converted into the specified form. So let's convert it into the specified string. So string message equal to new message, not new message, new string, and we will specify this bytes, and also we specify the 0, and we specify buffer dot, not hash code, buffer dot length. It's not the byte, it is basically buffer. Okay, so we are converting that message, the byte array, into the string form. Let's print out that string, system dot out dot println message. Fine. So this is all about the receiver code. Now the question is, which should run first, whether the sender or the receiver. Now if the receiver is not already running, then who will receive the message? So that's why we need to run the receiver first. So let's run this receiver first, and why not I give a message that the receiver is ready. System dot out println So now run this message, run this particular code, receiver. So here the receiver is ready. Let's run the sender. So sender was running and it is printing message sent, and when the message is sent, then it is received at the receiver end and it is converted into the string, or converted into the actual message, that is hello client. So in that way the client or the sender is sending the message and the receiver is receiving the message in UDP mode of communication. So that's all for this video. In the other video we will talk about URL and URL connection classes.